So yeah, this is kind of what we already talked about, kind of like the motivation behind why we would want to implement audio. And then I talked a little bit about the latency to understand how audio is processed, starting from when the file is on the phone until it does some magic and transform so that you can hear actual music on your headphones. So looking at this from like a hardware and software layer, so the music file is stored on your application somewhere, so it's stored on your phone, and then it goes through your audio framework where it has to do some resampling and effects and mixer, and then finally ends up on the device hardware through something called a digital analog converter, and that's how you hear the music. So this path is from the beginning to the bottom of how you play this, from the moment you start playing the sound till you actually hear it. This is the path of the latency that we're worried about, and we always want to minimize the latency in between when you play it till when you hear it, right? Because you don't want users to be hearing silent sounds in any situation. So audio hardware actually consumes data at a constant rate. This means that there's deadlines for when you can actually pass it music data for it to be consumed. And if you miss these deadlines, then you're gonna get some bad results. So when we pass these audio files to be played, we have to make sure it gets processed in time to meet the deadlines. So we have to make sure that everything it does in the previous slides is done in the right time frame. And if these are missed, then you get weird silent sounds or weird like static sounds that sounds like you're making popcorn or something. So this is like one of my favorite analogies for it. Actually, this was explained by someone at Google about how audio is processed. So if you can imagine, there's like this chicken trying to cross the road. Why does the chicken want to cross the road? Well, in this case, the chicken is audio, and it wants to cross the road to get to your headphones or whatever your output is. So it's trying to cross the road, but there's these cars coming at like constant times, and these cars can be thought of as the deadlines that you're trying to catch, right? So these cars are spaced apart very evenly, and that's how we kind of think about the deadlines. But at the same time, the chicken is behind this fence, and the fence is controlled by the Android kernel. So the Android kernel is the one opening the fence and allowing the chicken to say, okay, now you can cross the road, but there's also these cars coming, so there's all these factors in play right now, right? So sometimes the Android kernel does get like a little distracted, like he's trying to do other stuff, right? Because audio is not his only job. He has a bunch of other stuff to do. So if he gets distracted and he doesn't open a door at the right time, this is going to happen to chicken. And just gonna imagine the purple is the car coming, and the chicken is gonna get crushed. And in that case, that's when you get silent sounds or popcorn sound. So that's kind of a great analogy of how I finally understood how audio is processed. But after understanding how it is processed, now you actually have to think about how to implement playing the audio, right? So there are a couple of things that I looked into for alternatives of how to play audio. The first one was MediaPlayer, second one was SoundPool, and the last one was ExoPlayer. So we're kind of going to go through these one by one to see what they can do and they cannot do. So starting with MediaPlayer, this is the most simple one. So MediaPlayer can easily fetch, decode, and play audio with minimal setup. It's kind of like the most easy way if you just want to play one sound. And it supports local resources, so you could pack it into your APK, internal URIs, or external URLs for HTTP streaming. So if we just look at a very simple example here of how we play an audio file, the first thing you do is you just create a MediaPlayer, and in this try and catch block, you're going to set your audio stream type. So the audio stream type kind of lets Android know what kind of audio or stream you're going to play. So if you're saying, okay, this is a stream type for the music versus this is a stream type for a notification, it's going to have different volumes based on these different stream types. And then the next step, you're going to set the data source, which is basically where your audio is located. And finally, you're going to prepare the MediaPlayer and then start it. So once you call MediaPlayer.start, this is when you're actually going to start hearing sounds. And all this is in a try-catch block because MediaPlayer, it's very easy to be in the wrong state and try to do something when you can't. So you always have to remember to put it in a try-catch block. So when I mentioned before that you always have to put stuff in a try-catch block, it's because MediaPlayer state base is very complicated. It's meant to be very hard to see because there's so much going on. It's hard to keep track of what state the MediaPlayer is in and what you can and cannot do at a certain stage. And that's why it can easily cause undesired behaviors. So if we look at the different states that the MediaPlayer is in at each step, first when you set the audio stream type, it's at an idle state. So that means it's not really ready to be doing anything. It just kind of knows it's about to do something, but it's not actually ready to do it. And then when you finally set a data source to say, okay, this is what I'm gonna play, it's at this initialized state in which it's like, okay, I'm almost ready to play something, but not quite. And finally, when you call the prepare state, it's gonna be prepared, and that's when you can finally call methods like start, pause, or seek to. So some common errors that I experienced when implementing MediaPlayer was not handling like stuff that happens on the error and not catching what was going on and having like a hard time debugging things. Also performing actions in the wrong state because there are just like so many states to keep track of. And trying to play unsupported file types, MediaPlayer actually had really bad errors coming back from it, so it was a little hard to debug in that sense as well. And not releasing the MediaPlayer after use is really important because when you create a new MediaPlayer, it consumes a lot of resources, and the kernel has to like manage it and think about it all the time. So if you don't release it, then the kernel has another task to worry about. So MediaPlayer was what we used in the beginning when we just wanted to play simple sounds, and everything was just like, okay, you tap this like back button and it plays this sound, and you tap this check button and it plays this sound. But then we started to run into this more complicated case where we had a slider. So this is one of the screens on the oven that I work on. And in this slider, so designers wanted some like crazy like requirements for it, right? Like this is a slider, and every time you pass a big tick mark, we want to play a new sound on a scale. So if you like scroll the slider like this, it's like you're playing the xylophone or something. So then it's like, okay, but if the users like start scrolling really fast, then we don't have time to like load and unload all these new like media files, right? So what are we gonna do now? So that's how I started looking into SoundPool. So SoundPool is cool because it kind of just uses MediaPlayer in the background to decode the audio that you're going to play. But it has really cool features such as you could use a collection of samples from the APK that you have, and it could be loaded into memory. So that means that you don't have to load it into memory every time you want to play. It's already on, you can load it beforehand so that you don't have to do it when you actually want to play the sounds. It's also able to manage a number of audio streams. So that means you could play like 5 different sounds at once. So that was good for us in the case of the slider because that meant we could play like 5 different sounds on the keyboard once, and we didn't have to abruptly like stop one sound just to play another sound. And another great thing about it was you could set priority when you play a sound. So we had, on the oven, we had emergency sounds that says like, oh, your oven is like way too hot, like you should do something about it. And in that case, we should not play any other sound, and we just want to play the emergency sound, so this was a great case for that. So taking a look at the SoundPool example here, you build it with a builder, and you can set stuff like the audio attributes and the max streams you have. So for example, for us, we set 5 so that you could play 5 sounds simultaneously. And then you kind of load files into the SoundPool, and you get back this integer to keep track of all the files you loaded, and that's how you eventually play these sounds. And you could specify like what volume you want it to play at and whether you want it to loop and stuff like that. So that one, it's also really easy to set up and also really great for when you want to play sounds in a quick succession. So a great way to look into how like SoundPools and MediaPlayer works is just by going into the Android open source framework, right? That's one of the easiest ways to learn things. And audioservice.java is the one file in Android where all the sounds are controlled. So if you read through the whole like 3,000 line file, you'll figure out, oh, how does sound work on my phone? Like there's maximum sounds for different kinds of streams. Like Bluetooth streams somehow have a max volume of 15, while like regular sounds only have a max volume of 10 for some reason. So there's a lot of interesting stuff in there and different kinds of ideas of how to implement things. The last example the last alternative I looked at was something called ExoPlayer. I didn't actually end up implementing ExoPlayer, but a lot of people did suggest it, so I thought it was worth mentioning. So ExoPlayer, for those of you that aren't familiar with it, it's an open source project. So it's actually not part of the Android framework. So you have to import this extra library for your project. But the pros of that is that you get to update your player along with your application because it's not shipped with the framework, right? So you can update the library version instead of having to ship like a completely new framework. And this also causes less device-specific issues across different versions of Android since you know exactly what version of ExoPlayer you're using. And since it's like very extensible, you have a lot of power over how you want to use it. So the way I think about it is ExoPlayer is kind of like using a DSLR camera versus a point-and-shoot camera when you're using like a media ExoPlayer or SoundPool. So I didn't get too much into ExoPlayer because I didn't use it too much, but there are a lot of other great talks about ExoPlayer already out there if you're really interested in how to implement it. So one of the things about implementing audio is kind of thinking about the other apps that are on a user's phone. So your app is not the only app that the user is always using, and you always have to be conscious of the audio that you're putting out because it could correspond to how other apps are playing audio. So the main thing to focus on is something called audio focus. So audio from different apps can play simultaneously. Android just kind of mixes all of them together, and it doesn't have control over what does play and doesn't play. People just send it things to play, and it just mixes it all together into one giant stream. So if individual apps don't handle this audio focus properly, it usually results in a bad user experience. So if we take a look at a sample, so say the user is currently in your app and they're playing audio, and then it goes into another media app to play some more audio. If not properly handled, both apps at this time will start playing their audio stream and nothing will be heard because it's trying to play like two things at the same time. It's like two people trying to talk over each other and you can't really understand what either person is saying. So the proper flow of how this should have been handled is each app should request their own audio focus to say, hey, I'm going to play audio, so if you give me permission, I'm going to actually start playing audio now. And you start the playback after the audio focus has been granted to you, otherwise you're going to have the problem having two apps trying to talk over each other. And then you handle the audio focus through something called an audio focus change listener. So every app that subscribes to this listener will get callbacks whenever the audio focus has changed on a phone. So whenever you want to ask for audio focus from the system, you also have to say, okay, these are my intentions for using this audio. Like, what am I going to do with this focus? And there are a lot of different types, but the three main ones are audio focus gain, which means, okay, I'm going to use it indefinitely. So that's something like the Spotify player would probably use. There's also something like the transient, which is like, okay, I just need it for a little bit. So that's like what you would use if you were trying to call someone. And there's transient made duck, which is like something temporary, like a notification. So if we look at an example of how this is actually built and implemented, the first thing you do is when you create a new audio focus request, you have to say what your intentions are. In this case, in our example, our intentions are to gain it for indefinitely. And then you have to say, okay, even if I don't get it now, do I want it eventually, or it's a now or never kind of thing? And then, of course, you have to say, okay, when the audio focus change, you have to be responsible and say, okay, maybe if I don't have the request anymore, then I won't play audio anymore. And finally, you just request the focus and wait for it to be granted to play your audio. So for sound on the June oven, we had a lot of common sounds, such as taps and backs and cancels, versus special sounds, where you would play, say, when your food is done or when preheating is done. So for our common sounds, we put all those in the SoundPool because that allows us to easily play it very often. And for the special sounds, we played it through a MediaPlayer. And then we also had supported themes, so people could choose oh, I want a game version theme where it sounds like a blaster, versus a more subdued theme where it sounds a little more quiet. And then, of course, we had those emergency sounds where your oven is overheating or your food is about to burn, stuff like that. So we loaded all the common sounds into the SoundPool for a low latency, like I explained before, because then we wouldn't have to use the Android to call and load the sounds for every time we want to play it, which could be a lot of times and waste a lot of resources. And all the other sounds were played with the MediaPlayer. And sounds can also request to be played immediately, such as the emergency sounds that can happen now and should happen immediately before any other sound. So some of the problems we encountered, one of them was creating a pleasant experience on the sliders. So this was a difficult thing because we didn't want to play too many sounds at once, and that could create a really bad experience where it's just too many sounds jumbled together. So we had to make little sounds that kind of mix into the bigger sounds in a more pleasant way, and that was kind of complicated, and we didn't really come up with a great solution for that yet. Another thing was we wanted a sound to play every time we tap the oven and it kind of wakes up so that we can inform the user, oh, the oven is awake and ready to be used now. But this was hard because when the Android system goes to sleep, it kind of kills all the resources, so it doesn't like start draining battery and stuff like that. So at the same time, when you wake it up, it's not ready to play a sound because it hasn't like prepared all its resources yet. And playing a sound requires like creating a media player and everything that needs to be done before you could play a sound, which was like too little time to actually play a sound before the oven woke up. So we haven't solved that problem yet either. And another problem that we encountered was playing a sound when themes change. So when we changed the themes, we wanted to load a new sound pool or a new pool of sounds into the sound pool. And because it takes a bit of time to load all the sounds into the pool, like we couldn't play a sound immediately when the theme changed. So that was something that we haven't figured out either. And yeah, that's all I have. Thanks for sitting through the technical difficulties. And if you have questions, I'll be here for a bit.